You and I, we use software all day, every day. It's on our phones, our computers, everywhere. But if you ever stop to think about how it's actually made, it can seem like some kind of tech magic, right? Well, today, we're going to pull back that curtain.
No, really, think about it for a second. That game you can't put down, the app you use to chat with your friends, at one point, it was just an idea in someone's head. So how in the world did it make the jump from their imagination right into the palm of your hand?
You might think it's just this chaotic burst of genius from a bunch of coders fueled by pizza and energy drinks, but nope. Building software that actually works and keeps working is a surprisingly disciplined journey. It's a process designed to take a messy, complicated idea and turn it into something organized and reliable.
See, at their core, all these apps and websites are what engineers call systems. And that's just a fancy way of saying there are a bunch of different parts all working together for one specific reason. You know, whether that's to help you order a taxi or to show you a million cat videos. Okay, so if you've got all these different parts, how do you manage them all without it turning into a total mess? Well, you need a master plan. And in the tech world, that plan has a name, the System Development Lifecycle, or just SDLC for short. Think of it as the official roadmap that guides a project from start to finish.
And here's what that roadmap looks like. It's a journey broken down into 7 very specific phases. This is the exact path we're going to walk through together, from a simple what-if idea all the way to a fully functioning app.
All right, before anyone even thinks about writing a single line of code, every project has to start with what's called a preliminary investigation. And it all boils down to one simple, absolutely critical question you see right here. Should we even build this thing? This is the moment you decide go or no go, and it's what stops companies from wasting a ton of time and money on a bad idea.
So let's say the idea gets a green light. The next step is a much deeper dive called a feasibility study. The best way to think about this is like building a house. Before you start digging the foundation, you got to make sure your dream home can actually, be built.
And that study asks 4 key questions. First, technical. Do we actually have the skills and the tech to pull this off? Then, economic. Is this thing going to make money or at least pay for itself? Third, operational. When it's built, are people going to find it easy to use? And finally, organizational. Does this project even align with what our company is trying to do? If the answer to any of these is no, the project usually stops dead in its tracks.
Okay, so the project is a go. It's feasible. Now the real fun begins. The team has to get super specific about what this system is actually going to do. This is all about defining the dream. And these specifics, called requirements, come in 2 main flavors. You've got functional requirements. That's the what. The system shall let a user log in. It's non-negotiable. Then you have non-functional requirements. That's the how well. The system should load in under 3 seconds. It's all about the quality and the feel of the app. And check this out. Here's a simple little rule of thumb that the pros use. The language is everything. If you see the word shall, it's a deal breaker. It has to be in there. If you see should, it's more like a really strong suggestion. That tiny little word choice makes a huge difference in how the work gets prioritized.
All right, we know exactly what we need to build. Now it's time to draw up the blueprints, and then, just as important, it's time to try and break what we've built.
So first up is the system design phase. This is where all those shall and should statements get translated into a technical blueprint. This document is basically the holy grail for the developers. It tells them exactly what to build and how all the different pieces are supposed to fit together.
Now, the second you start building, you also have to start testing. And there are really 2 ways to think about finding bugs. Imagine a car. You could be a mechanic, popping the hood and looking at the engine itself. Or you could just be a driver, taking the car for a spin to see how it feels on the road.
In software, that's white box versus black box testing. White box testing is for the mechanic. The tester looks inside the actual code to see if the logic is sound. But black box testing is for the driver. The tester has no idea what the code looks like. They're just using the app like a normal person, clicking buttons and making sure it all works as expected. And testing isn't just one big event. It happens in layers. It starts really small, with unit tests on tiny individual functions. Then comes integration testing to make sure all those little pieces play nicely together. After that, you do system testing, where you test the whole dang thing from start to finish. And the very last step is acceptance testing. That's when you put it in front of real users to get their final stamp of approval. So, the system's built. It's been tested like crazy, and it's finally ready. Now comes what's probably the most exciting and terrifying part of the whole process:
actually launching it to the world.
I mean, think about it. This is a huge challenge. If you're a big company, you can't just turn off your old website and hope the new one works for millions of people instantly. You have to have a smart strategy.
And there are 4 main ways to do it, each with its own trade-off between risk and cost. You could go direct, the Big Bang approach, where you just flip the switch. Super risky. Or you could do parallel, where you run the old and new systems at the same time. It's safe, but really expensive. Phased means you roll it out piece by piece. And a pilot release means you give the new system to a small group of people first. For instance, a big app might pilot a new feature in a small country before ever releasing it to the rest of the world. But here's the thing that so many people get wrong. Launch day is not the finish line. It's not even close. Good software isn't like a building that you finish and just walk away from. It's way more like a garden that you have to constantly tend to if you want it to stay healthy and grow. And that tending is called maintenance, and it comes in 4 flavors. You've got corrective, which is just fixing bugs. Adaptive is when you have to update your app to work on the newest phone operating system. Perfective maintenance is the fun stuff, adding cool new features people have been asking for. And finally, preventive is all the behind-the-scenes work to stop future problems before they can even start.
So what's the big takeaway here? Creating the tech we all depend on every day isn't about some random flash of genius. It's about having a clear, disciplined process that can reliably guide a team from a messy, chaotic idea all the way to a polished, working product. It's all about turning chaos into order.
And that leaves us with one last thing to think about. As technology gets exponentially more powerful, we're talking about AI that can code itself, quantum computing, things we can barely imagine. How will this fundamental 7-step process of creation have to change and evolve to keep up? What will it take to build the software of tomorrow?